Hello everybody and welcome back. We're on question number 24 of the 2003 grade 7 level Gauss competition. Not the grade 8, nope, it's the grade 7 and we're almost done it too. In the pattern of numbers shown, every row begins with a 1 and ends with a 2. Each of the numbers not on the end row, so the 3, the 4, the 5, the 9, things like that, is the sum of the two numbers located immediately above and to the right. Immediately above and to the right, and immediately above and to the left. Okay. So, for example, this 3 here is the sum of the two numbers above it, the 1 and the 2. This 9 is the sum of the 4 and the 5 above it. This 7 is the sum of the 5 and the 2 above it. Okay. If you've ever seen Pascal's triangle, which is a great little mathematical, artifact, it's done similarly, except it's got 1s all along the side. And I suspect whoever made this question was thinking sort of Pascal's triangle. So, for example, in the 4th row, the 9 is the sum of the 4 and the 5. That's exactly what I said. If this pattern continues, the sum of all the numbers in the 13th row is... Okay. So we got ourselves a 1st row, 2nd row, 3rd row, 4th row. They even double check and tell us that this one here is the 3rd row. The reason I make note of that, if you are aware of Pascal's triangle, if you've studied it, you know we typically say that Pascal's triangle starts with the 0th row. So I like double checking that the 3rd row, by counting, is actually called the 3rd row. You might expect, if you go, aha, Pascal's triangle, you might say, oh, well, then we're starting at the 0th row. No. The 3rd row is the 1, 4, 5, 2. They even tell us that in the question. So that way we truly know what the 4th row is, and then we can work out the 5th row, 6th row, 7th row, 8th row, 9th row, 10th row, 11th row, 12th row, 13th row. That's a lot to say. And it's going to be a lot to calculate. You'll notice the 1st row has 2 numbers in it. The 2nd row has 3, then 4, then 5. So by the 13th row, we're going to be writing out 14 numbers. And on the row before that, we had to write out 13 numbers. So it's going to be a lot of calculations. Now, I'm not saying we can't do that. If you've got the time, go for it. But there's going to be smarter ways to do the question. And when it comes to trying to figure out the 13th row, it's crazy. Even looking at our possible answers, they're all in the 12,000s. These are our possible sums. I'm not wanting to do that calculation. And we're not expected to. So if we want to better understand the 13th row, it might be a good idea to take a look at the 2nd row, the 3rd row, the 1st row. Examine these rows. See if we can find patterns. We're being asked about the sum of the numbers in the 13th row. How about we work out the sum of the numbers in the 1st row, the 2nd row, the 3rd row. See if we can see a pattern. If we can see a pattern with the numbers in the 4th row, in the first 4 rows, we can say, oh, I think this is the pattern. Let me predict what the sum of the numbers should be in the 5th row. And then we can work out the 5th row and see if we're right. Okay? That would really give us an edge. If we can even explain why this pattern's happening, that's even better. Okay? So with that in mind, how about we start calculating the sums of some of these rows? So I'm going to go over to my notebook. I'm going to flip the page from that wonderful dice question. And I'm going to start copying here. So we've got 1, 2, 1, 3, 2, 1, 4, 5, 2, 1, 5, 9, 7, 2. These are the rows I'm given. And the sum of the first row is 1 plus 2 is 3. The sum of the next row is 1 plus 3 plus 2 is 6. How about the 3rd row? What's the sum of those numbers? 1 plus 4 plus 5, so that's 10 in total, plus another 2, that's 12. 1 plus 5 plus 9, that's going to be 15. Plus 7, that's 22. Plus 2, that's going to be 24. So we can notice that, how do I get from the 1st row to the 2nd row? I multiply by 2. Then the next row, from 6 to 12, that's multiplied by 2. 12 to 24, that's multiplying by 22. So my guess is, to get the next row, the 5th row, the sum of those numbers, I should be multiplying by 2. 24 times 2 is 48. So I'm going to guess that it's 48. So that's my guess for the 5th row, just to test my theory. Well, what is the fifth row? It starts with a 1. Then it's the sum of this 1 plus 5. So that's 6. The sum of the 5 and the 9, that's 14. The 9 plus the 7, that's 16. The 7 plus the 2, that's a 9. And then we end with another 2. Okay. So what's the sum of these numbers? Well, the 6 plus the 14, that's 20. The 1 plus the 9, that's 10. So that's a total of 30 so far. 16 plus 2 is 18. 30 plus 18 is 48. We were able to correctly predict a number. If we were unsure, we could go a step further. We could calculate the sixth row if we wanted to and figure out the sum, and that should be 96. Okay? And if we're confident in this pattern, because this is a pretty basic pattern, we can now jump all the way and guess what the 13th row is. Okay? We can even grab our calculator and say, aha! All right, so the fifth row I just figured out is 48. So to multiply by 2, I have the sixth row. Multiply by 2, I get the seventh row. Okay. Multiply by 2 again, I get the eighth row. Multiply by 2 again, I get the ninth row, and the 10th row, and the 11th row. I count off to myself. And the 12th row. And now, the 13th row, I get 12,288. So 12,288. That is my guess for the answer. And that was one of the answers, I believe. If we go back to the actual contest paper, D, 12,288. That's going to be our answer. Okay? But we can go a step further and convince ourselves that this should be the answer by asking, well, what's going on here? If my previous row is something like A, B, C, its sum is A plus B plus C. Okay? Now, what happens? I duplicate the first number, the numbers on the ends, and then I say, well, this next number, this one right here, is the sum of the previous two numbers. And this number right here is the sum of the two numbers above it. And when I add these up, I get 1A plus another A, so that's 2 A's. I get 1B plus another B, that's 2 B's. 1C plus another C, that's 2 C's. So this will have a sum of 2A plus B plus C, no matter what my A, B, and C were. And this will work for rows of any arbitrary length. Okay? We duplicate the first and last, so that gives them their copies, and then every number is used twice. So of course we're going to double the row. We can even see that in this row, in this sequence, just by looking at it and not simplifying. So here's our 3. We get 1 plus 2 here. Okay, so there we've got 2 1s and 2 2s. Now if we simplify, we get 1, 2, 3. How do we get the next row? 1, 1 plus 3, 3 plus 2, and another 2. We've got 2 1s here, 2 3s, and 2 2s. So it's going to be double the previous row. And that simplifies to 1, 4, 5, and 2. Let's get the next one. We get our 1 and our 2, and then we have 1 plus 4, 4 plus 9, or 4 plus 5, 5 plus 2. If we were to add up this row, we've got 2 1s, 2 4s, 2 5s, 2 2s. We really are doubling every single number. So the sum of the rows doubles. And so our answer is going to be 12,288, and we said that was D. Okay? If you want to, I encourage you to try and find a formula. Pause the video right now and see if you can find a formula for the sum of a particular row, the nth row. Okay? So hopefully you've gone and paused that, play the Jeopardy music in the background while you think for a moment. Pause the video, come back, because I've got an answer for that, and it's a good way to double check whether or not you can recognize patterns and transform them into a nice closed form type of function that you can just plug numbers into. So if you were to be able to successfully get this formula, you would be able to plug it very simply into your calculator to be able to tell me what the sum of the numbers in the 20th row is, for example. And that's useful, because maybe next time they're not going to ask us 13. Maybe they're not going to ask us 13, because 13 we were able to just go, okay, times 2, times 2, times 2, times 2. But if they asked us for the 1300th, at that point we need a formula to try and get it. Okay? So coming back and having given you ample time to pause, I think the sum of the sum in nth row is, well, I've got 3 in the first row, and then every row after that, there are n minus 1 rows after that, we just keep multiplying by 2. So this is my formula, 3 times 2 to the n minus 1. Notice that this checks for the first row, 3 times 2 to the 1 minus 1, or 3 times 2 to the 0, that's just 3 times 1, or 3. How about the fourth row? 3 times 2 to the 4 minus 1, that's 3 times 2 to the 3. That's 3 times 8, that's 24. Okay, so that's just a little extra. We didn't need to actually work that out to solve the question. We solved it a little while ago. The answer is going to be D. But now we better understand why that's the answer, and we were even able to go a little further and generalize to a nice little formula. And I think that's not bad, and that's the sort of curiosity I like to infuse into going through these math questions. Okay, so we've got one more question to go, and that's going to be question number 25. So that'll be the final question. Have a look at it if you haven't already, and I'll see you guys in the next video.